In this lesson, we're going to continue working on solving equations, and we'll add some extra steps and also look at how we can use equations to solve application problems. So the first thing we're going to do is look at equations that have parentheses in them, and we'll use the distributive property when we're solving those. And you may have seen this where we did this with arrows previously to remind us to multiply by everything that's in the brackets. And so we'll first use the distributive property, and at each stage of the process, if we can simplify one or both sides of the equation, we'll do that before we're moving on to next steps. So in this case, we're going to multiply through those parentheses. So we'll have 8x minus 4 minus 7x equals 9. And notice that we've got an 8x and a negative 7x, so we'll combine those. So now we have x minus 4 equals 9. So we'll add 4 to both sides of the equation so that we get x equals 13. Okay, so in this stage we're collecting like terms, and you don't need to show that you're doing that step. You can just do it collecting like terms, so terms where the variable and its powers are identical. We could then also take the 13, our solution, and substitute it into the original equation. And I'm going to try to do that in smaller font here. Maybe I can do it by expanding the screen a little bit. So I've got 4 times, 2 times 13 minus 1 minus 7 times 13 equals 9. So I'm substituting the 13 in for x in the original equation. So now I'm going to use order of operations to simplify the left side here. So I've got 2 times 13 minus 1 in one set of parentheses here. So that gives me 25. So I've got 4 times 25 minus 7 times 13. So that'll be 70 plus 21. So that's 91. So 4 times 25 is 100. 100 minus 91 will give me 9 equals 9. So the left side does equal the right side. So our solution is correct. Going to go back to our original size here, and let's look at question B. I've got a set of parentheses in here, and again, using the method that we did before of consider that to be a negative 3 that you're multiplying by each term in the parentheses, and then each of your terms will have the right sign right away rather than having to then subtract terms that may be negative. So when I do that, I'm going to end up on the left side with 10x minus 3x plus 12. Negative 3 times negative 4 giving me plus 12 equals 9x minus 8. I'm going to notice that I have 2 x terms on the left side, so I'm going to combine them so that now on the left I have 7x plus 12 equals 9x minus 8. And now I can decide which side I want my x's to appear on, and often students prefer to see the x on the left, so we'll subtract the x that's on the right side of the equation. So if we subtract 9x from both sides of the equation, we end up with negative 2x plus 12 equals negative 8. And now to isolate the x on the left side, we'll subtract 12 from both sides of the equation. So on the left side, I now have negative 2x, and on the right, I have negative 8 minus 12, or minus 20. Now I'll divide both sides by negative 2. So now I have x equals positive 10 as my solution. And again, I could substitute that in, and I have to double check my work, and so just trust me, it is correct. All right, now let's take a look at our next step here, which is looking at how do you take words and turn them into equations. If we'll look at a couple of examples, and this really, you do get better at this with practice, but I'm going to just show you a few tips here for helping to figure that out. When we are given words or an application, the first thing that is important to do is to define what are your variables going to be. So if we look at this first example, the length of a rectangle is 8 meters shorter than double the width. This could be written as an equation. So let's turn these words into an equation. The first thing to do is to define what are our variables. So let's let L represent the length of the rectangle. And then we'll let W represent the width. Now that we have L and W, and we could have used different letters, but it's often helpful to use a letter that helps you to remember what it is, we could say that the length of the rectangle is, to me, that is represents the equal sign. So we could say L equals, the length equals, it's 8 meters shorter than double the width. Well, double the width means 2W, right? We're doubling the width. And to be 8 meters shorter than that would be to be 8 less than that. So we could write it as 2W minus 8. We could also have written it as negative 8 plus 2W, but most people would agree that this is the form that would be a little bit easier to understand and possibly to work with as well if we needed to do some more work with that equation. There are more ways to write that, but this way goes directly from the sentence written to the algebra. We could also have said, well, if the length is shorter, that means we have to add 8 to it to get to twice the width. So we could have written that as L plus 8 equals 2W. So the length plus 8 meters is equal to double the width or twice the width. But if you think about it, these two are the same equation. We've just added 8 to both sides on the one on the right. Let's move on to example B, where the question is the temperature in Rome was 21 degrees higher than in Sheffield Mills. So again, we're talking about the temperature, but we're talking about two different temperatures. One is in Rome and one is in Sheffield Mills. So we might let R represent Rome's temperature. And we might let S represent Sheffield Mills temperature. Okay, so if we do that, then we could say that the temperature in Rome was, so we could say R equals 21 degrees higher than in Sheffield Mills. So that would be the Sheffield Mills temperature plus 21. So now we've created an equation based on those words. So now let's take a look at doing an application and creating an equation for it and solving the equation. In a Scrabble game, there are 3 times as many A tiles as G tiles. The letter O occurs 2 more than twice the number of G tiles. The total number of A, G, and O tiles is 20. How many of each tile are there? We could look at this and think about, especially the last sentence would tells us that we might want to do something like let A represent the number of A tiles, G represent the number of G tiles, and O represent the number of O tiles. And we could do something like A plus G plus O equals 20. but we have 3 different variables here, and at this point we only are working with equations that have 1 variable. So there is enough information here for us to turn this equation into an equation that has just 1 variable. And if you think about it, in this part here, we're saying there's 3 times as many A tiles as G tiles, and there's 2 more than twice the number of G tiles gives us the O tiles. See how both of those, the A and the O, are compared to G? So that means that we can solve this problem using just the number of G tiles as our variable. So and I'm just going to use lowercase here, let G represent the number of G tiles. Okay, so if we look at this equation that we wrote already, A plus G plus O equals 20, let's see how we can translate that to using just the letter G. So the capital G down up there, we can just represent with our lowercase g. Now there are 3 times as many A tiles as G tiles, which tells us that really we could write the number of A tiles as 3G, because the A tiles are represented by 3 times as many G tiles. And then let's take a look at the O tiles. The O occurs 2 more than twice the number of G tiles. So twice the number of G tiles is 2G, and 2 more would be plus 2 equals 20. So we've taken this first equation, and now we've written it with just 1 variable, and now we can solve that equation for G. So I'm going to collect my like terms, and I have 6G plus 2 equals 20. I'll subtract 2 from both sides, so I have 6G equals 18. And I'll divide both sides by 6, so that G now equals 3. Now I've solved for G, but have I answered the question how many of each tile are there? I've really only answered how many G tiles there are so far. So we're going to, and I switched to the next page to do that. Remember that we decided that the letter A was equal to 3G. So if 1G is 3 tiles, then A must be 9. So there are 9 A tiles, and there are 3 G tiles. And remember that the O was 2G plus 2, so that's 2 times 3 plus 2, so that means there are 8 O tiles. Okay, so now we have answered the question of how many A's, how many G's, and how many O's there are. And we can double check based on the question. We can see that the total number of tiles is 20, 9 plus 3 plus 8. We can see that there are 3 times as many A's as there are G's, and we can see that there are 2 more than double the number of G tiles gives us the number of O tiles. So we can double check that that answer is correct. And again, this type of problem gets easier with practice. You start seeing the patterns of the language and deciding how you can represent what it is you're looking for using variables and creating an equation that you can solve to find the answer. And that's it for this lesson.